Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous video tutorial, we generated two land use, land cover images from the Sentinel daytime images and the corresponding dynamic world images. So we created two images. I called it, in my case, a pre-image and a post-image, meaning in 2015 image, I think it was August, and then a 2023 image, also August. And then what we wanted to do was to visually detect any changes, locations where there's significant land use, land cover changes. And to do that, we actually generated a split screen where we presented simultaneously both the 2015 and the 2023 land use, land cover images. And then we, using the split screen, we can then identify areas where there was, for example, increase in built-up areas, or where there was an increase in water, or where there's a decrease in this or that, whatever the case might be. So that was quite neat in that we created two very nice looking images using, as I said, the Sentinel daytime images and the dynamic world images. Okay, so that was quite neat. And I said it's all based on visually detecting change, land use, land cover change. But that just gives you an intuitive idea of where there has been changes or where there hasn't been changes, but we cannot quantify those changes. We can just visually, look at it and say, okay, there was this or that's what's happened, or what X, Y, and Z. But we don't know the numbers, how much bare soil was there, for example, in 2015, how much bare soil was there in 2023. Intuitively, we can say there has been a decrease in bare soil simply because there's been quite a bit of rain. There's much more increase in water, and because there's an increase in water, there's an increase in vegetation and so forth, and therefore there's been a decrease. So that we can say from just purely visually looking at the two images side by side, as I said, within the split screen format within it. So that was quite neat, but I said it's a visual stimulation or a visual sensation, but we don't know the numbers. We can't quantify this per se. We can qualitative say X, Y, and Z, but we cannot quantifiable say, okay, this was 2015, now this 2013, this is how much it changed, etc. per the 9 categories of land cover classes. Okay, so what we actually want to do now is to say, okay, we want to actually calculate some statistics that actually will back up our visual detection. Okay, our visual land cover, land use change detection. We want to get some numbers so that we can back up what we actually qualitatively are saying. Okay, so we're going to stick with our region of interest, or our Veldrift town. Okay, so I added that in, map center, clip, so all the standard stuff, nothing towards it. But what we're going to do now is we're going to calculate statistics for our region of interest. Okay, specifically we're going to focus on built up. Okay, what was the number of built up, call it pixels or locations within our region of interest, and as a percentage of our total region of interest, what is our built up footprint. Okay, so is it 10% of our region is built up? Is it 20%? Is it 40%? What percentage of our region is built up? If we specifically just look at this, intuitively one would say it looks almost like a 50% built up area. Okay, but we don't know. It's just intuitively, visually, it suggests that it's quite a large area, and therefore it may be quite large, but we don't know. Okay, so we want to calculate those numbers, and then obviously we want to generate the numbers for each of the classes, and then obviously we can generate it per image or per year, and then we can compare qualitatively what was the change that occurred, and that backs up our visual or qualitative analysis. Okay, so let's stick with our dates. Okay, we've got 15 of the 8th, 15th of the 8th, and that is our dates that we have in our initial one. Remember that date's there, so let's stick with the start date there. Remember we also initially had it 15th of the 8th in this particular one, but because we looked at different regions for which there weren't 2023 daytime images, we then changed it to the 10th month, but it's still quite close enough to the 8th month. So we're going to stick with this for now. And with the 8th month, and the idea is again to generate, let's say for 2023, the same for the 8th month, and then qualitatively compare the numbers. Okay, I like numbers, so let's work in the numbers space rather than just in the visual space. So I've got my start date and my end date as per normal, and I call up my dynamic world image for that specific time. I know there's the image for that time because that was in our previous tutorial, so we know we've got that date, so I don't have to go and guess or call a first one or whatever. I know there's only one image in that specific time. Okay, so we clip it, normal stuff, and then what we're going to do is we're going to in our classification, we're going to classify it. Remember, I've got all the pixels now, so I'm going to classify it based on my mode reducer. Okay, now what that does is, remember mode, what is mode? Mode is the one that occurs the most. So for that specific area, if built up is the most, then we'll identify built up. In that area, if water is the most, then we call up water. So we're calling up now using the mode statistic that feature, that land cover that occurs the most. Remember, for each location, it calculates a probability of all the land cover types. Remember, there's 9 land cover, water, I can't remember them all now. There's all of them. Let's just show you again. Remember, there's all of them. And remember, for each location, it gives you a probability of these 9 ones, which obviously adds up to 100%, which is a probability distribution. But what we're doing now is to say, okay, I don't want the probability, I don't want the probability distribution for each location. I want the land cover that occurs the most. Okay, so therefore I want to generate a mode. If I calculate the mean or the median, so water might be the predominant class for that location, but if we have a mean or median, it might say it's grass, because remember, all of them are prevalent at that location. Okay, so what we want to say is, okay, within this 9 categories or in this 9 classes, generate the one that occurs the most. Okay, that has the highest probability, and that is what we're doing here. We just go there. We're saying to Earth Engine, display that land cover that occurs the most for a specific location. I don't want the probability distribution, because that gives me indication of all 9. Just tell me which one is the most. Is it water? Is it bare soil? Is it whatever? Doesn't matter what the percentage is, the distribution, just which one is the most, even if it's by 1%, which one is the most. And that's what we're basically doing there. Remember, label is the band. We go again to our landing page for Dynamic World. You see there's label. Okay, so we're going into this, and this gives us the one with the highest probability. Okay, so we're calling up this one, this band, and we're saying within this band, give me the one with the highest. Okay, give me the one that occurs the most. And remember, in statistics, the one that occurs the most is called the mode, and that's why we're using the mode reducer. Okay, in this case, so we now generate a classified area. If we generate a classifying area. So if you look at that, it only gives you one. So if I press here, let's say there, you see it will give me 0. So it doesn't give me a probability distribution. It only gives me the one that occurs the most. Remember, 0 is water, and so I pressed on water. So if I had to do it here, let's say there, which is the same plus minus area, it will give me the probability distribution. See, there's the probability distribution, and I know it's water. So water occurs the most, so therefore it's the mode. So therefore it only gives me a 0 or water. It doesn't give me the probability, and that's the function of this specific script. It calculates the mode, gives me the one that occurs the most. Okay, and then I'm going to extract my building class, because I'm interested in my buildings, how built up areas. What is the size or the footprint of my built up area for my region of interest? So that's what I'm interested in. Therefore, I'm extracting the built up number of pixels, or the built up footprint, and I'm using my composite, this one here that I've just generated. Okay, that's one here. I'm using that variable, and I say get me class number 6. Okay, get me class number 6. Okay, so if I go back into my landing page, class number 6, remember 0, 1, 2, 3, 4, 5, 6. So this is class number 6. So therefore, give me class number 6. Now, so if you're interested in water, you'll just change that to water. And you can call it water area, for example, whatever you want to call your variable. Okay, so if you want to determine other classes rather than built up, just change that number. Okay, whether it's a 0 for water, trees would be 1, grass, etc., etc. So just use that number. Okay, so so in this case, as I said, I'm interested in using built up. I'm not interested in other functions. But as I said, if your interest would be in something else, just change that number. Okay, change it based on based on this landing page. Where there? Okay, sorry, based on this landing page. And remember, it starts with 0, not 1. It starts with 0. Okay. Then standard practice in terms of visualization. There's the bands of the categories or the classes of land cover from 0 to 8 or from 1 to 9, and we stick with our color palette for our classes. Then we're creating our composites. So we're going to display map layer, this one here that we've calculated here, which is based on a single class of land cover, not the probability distribution. And then I'm going to add my layer just for build up. So I'm adding here the normal classification layer that I've calculated here, and here I'm adding a layer which is just build up. So there's my classification. As I said, it gives you a singular class. It doesn't give you a probability distribution, and then there's a one for build up. So 1 for build up, 0 for no build up. Okay, so white would be build up, black would be no build up. Okay, then there's a renaming of the bands, just to show it's not gonna, we don't want it 0 and 1, we want water build up. So we want the word classification, not the number classification. So that's what we're doing here. Okay, we're just renaming it from 0 to 8. We rather just want to say, you don't want to go 0, give me water. Don't want 6, give me build up. And that's what we're doing here. Okay, so that is now generating the necessary images and names that we're going to need. Now, what we want to calculate now is to say, okay, two things. How many pixels are built up, or how many of my locations are built up, and how many locations are in general. Okay, and then I can calculate the proportion. Pixels are built up as a proportion of total area. So this is what we're doing here. So first what I'm going to say is count all, calculate all pixels. Okay, so total built up, okay, or total area, and that will give me my total pixels. So what is my total pixels? And that's it. Remember, built up is a rename of all the classes. Say, I'm doing a count statistic. Okay, not mean or median or what. I'm using a count because I'm looking at interesting absolute. Remember, percentage is using two absolute numbers. So I'm interested in absolute number of built up areas, absolute number of total areas, and the two combined will give me percentage. So that's what I'm doing here. I'm calculating, in this case, all the pixels, okay, and in this case I'm calculating all the built up areas. Okay, so those are the two things that I'm doing in this particular column. Okay, so I'm using this at the moment. Okay, so I'm calculating two statistics here. I'm calculating the built-up areas, calculating all my areas, and then I'm calculating all my built-up areas. And so what I'm doing here is, as I said, in this piece of code is to say, okay, give me the percentage, i.e. fraction of my built-up areas divided by all my areas, and then obviously multiplied by 100. So there I'm getting my percentage of my built-up areas. Now if you change this from a 6, where is it now? Oops, okay, there. Then you can obviously just change it there, and rather use it built-up areas, just say water areas, and then you just change it all. So then you can calculate not just the built-up areas but all the other stuff. Okay, so this is what we ultimately then displayed as a fraction, and it will be a 2 decimal fraction, percentage 2 decimals. That's what we're doing here. So once we've calculated our total pixels and our total build-up, we generate our percentage. Okay, and then we're doing the same. We're calculating for all the classes. We're calculating the number of pixels for all the classes. And the rest of it is basically just saying, okay, let's print a histogram, this one here, and export the histogram of all the classes. Okay, and as I said, we're going to display it not in terms of zeros and ones and twos, but in terms of its names. Okay, so this is basically what this code is all about. Is first of all to generate, if we go there, to generate the image, and then to convert the image into its classification, meaning its classes, and then to count the build-up, and then to isolate the build-up area, then to calculate all the pixels, then to calculate just the build-up pixels, and then to display the number of build-up pixels or areas, and then to calculate the percentage. Okay. And then we also all the pixels, all the other classes itself, and then we're going to export that, and we're going to display it as a histogram. So that's quite a mouthful. It's all the things that we're doing in this piece of code. Remember to save. Okay, so let's see what the outcome is of all this stuff. Okay, so let's go to the console. So let's go to the first statistics. Okay, so I've showed you the two images. I'm not going to go to the two images. Those are the add layers. Those are those two images, which is the classification based on the mode, meaning the one that curves the most, and then a classification just as built up. So those are the two ones that's there. But that's not what we're not interested in that really. That's why I'm going to not too stressed about that. What we're interested in is, okay, we want to generate the statistics. Okay, so the first thing is all the pixels. Okay, all the built-up pixels, areas or pixels. I mean, pixels are that little squares. So let's calculate all the built-up pixels now, all the built-up areas. Okay, and that gives you 65543. So 65,543 pixels. Okay, so remember each pixel is plus minus 10 meters, ne? So that's the resolution. So each square is 10 meters, 100 meters squared. Okay, so you can multiply to find out this the total pixel size. These are just a number of pixels. Okay, because it's based on counts. You see, that's count. Now you can sum it. Obviously, that will give you a much higher number. So if you can sum it as well, huh? But remember, if you do the one sum, you have to do the other sum. Okay, so there is within this region of interest, in this area, okay, there is 65,000 pixels. Okay, pixel is 100 square meters. You can do the calculation. How much of that is built up area? Okay, how much of that is built up area? And this is what we get here. And it tells you about 30%. It looked much more to me if I just look this. It looks much more than 30%. But anyway, yeah, it's a third. Well, could be, because this is a whole lot of water here. So okay, okay. Visually it looked more, but that's why it's important to calculate the statistics. Okay, so that's why it's important. So that's what we've calculated here, is the number of built-up areas. Remember, it's important to generate the classification, because otherwise you have to work on zeros and ones and do your calculations on zeros and ones rather than on water, built up, etc., etc. So that's why we convert it, rename the bands, because remember the bands are named zeros and ones, and we want to convert it into water, etc. Okay, so that's the first thing that we calculate. And then, as I said, we want to calculate it. The second stuff that we're doing is we're calculating all the classes, okay, which is this one here. But you see, it's based on a 0 and a 1. So 0, now you have to go back into your dynamic world and say, okay, what is 0 again? 0 is water. Okay, and you don't want to do that. So, and that's what we're doing here now, is to say, okay, let's rename it again back to these classes, and that is what, and then print it. This is what we're doing here. Print it. So therefore, and it will now be alphabetic. Bare soil, build, crops, food. So you see there is water, 68240. You can see there water, 68240. It's just alphabetic. Okay. And obviously this is by ranging from small to high, and this is alphabetic. Okay. And then we display this number, these numbers, and the histogram. You'll see there. Yeah, we display that as a histogram. You can see there, there's the histogram. Now that's for 2015. Eh? So what I can do is, I have copied this. I just go like this. And copy, and I've pasted it Excel. That one there. You see water 61963. Water, no, in this case it's now 68240. Maybe I use a different. Let's run it again. Let's see, where did I get the 61963? Let's have a look and see what it says. Okay, 61. So maybe I just, okay, so let's do this now again. I'm going to copy this. Copy, and I paste it into Excel. Let's do another one. I'm going to paste it into Excel. Now, it doesn't paste very nice, but you can always just quickly fix it up doing this and put it down. I'm not gonna do anything now. I'm just leaving it as is. Okay, just leaving it as is. Oh, I used different time periods. Okay, that's why it was a bit different. I used the original 10th month. That's why that number is a little bit different. Okay. Remember, it's the same. It's, or I can just basically, let's do this as well. I expand on the histogram. Okay, so there's my numbers, and there's my histogram of those numbers. Okay, so I've done it now for 2015. So let's say I now want to change it to 2023. So all I'm doing, I'm changing the 15 to 2023. So let's, again, remember, we're not interested in the visual stuff. We've got that. What I'm interested is in this. Okay, so I do go to properties here. You see the 65 is still the same. We're going to do that now. So I just copy this again. I copy it. I go to Excel and I paste it in, and I just copy that format and I paste it in there. Okay. Now I'm just going to get rid of the formulas and paste it as values. Now I'm going to just delete these rows. Just delete these rows, and it's deleted. I'm going to delete, oops, why I haven't delete this, delete that row. I'm going to delete that column. Oopsie, why haven't I? Okay, so water, sorry, I'm going to delete that. I haven't deleted a couple of rows now. Let's delete that one and delete this one, and I'm just going to include a row there and say that's 2015 and that's 2023, and voila, there I've got my numbers. Okay, format this a little bit to make it a little bit more pretty. So I go number, 2 decimals, and there we go. So now I'm going to go change detection. I'm going to do a percentage change. So I can now go and say, okay, that, come on, I'm going to do this, minus this one, divided by that one, multiply by 100. There it is. Okay, so I'm going to do this and center it and drag it down. So, according to the analysis, bare soil decreased by 22%, crops increased by 30%, flooded vegetation increased by 35%. Look there, grass decreased by 36%, shrubs decreased by 78%, snow and ice, well, I don't know where they get that from, but look at trees increased by 107%. So that gives you an intuitive view, and obviously you can convert this pixels now into size, land covers, because we know each pixel is 10 square meters. So if I add this up equals to sum, then and I close that, it gives me the total number of pixels, and therefore if I take the 65, so I can also divide each one of them now. So I can get as a structure, a land use land cover structure for my area, times 100, and just format this one there, and I anchor the denominator, anchor the denominator. Oops, I should have done, okay, so I'll just convert this to C, and there we go. You can see there, built up 28% in 2015 and 28% in 2023. So it increased very marginally, if any. But you can see that trees covered 3.63% in 2015. Trees are now 7.52%. The built is the highest single classification. If we looked at water and built, okay, water and built is the two major land cover types, classes of land cover. You can see the rest. So once you've generated the statistics, okay, so let's just quickly, we can export this one as well. So there is the histogram. Let's just swap this around. There's the histogram for 2015, and there's the histogram for 2023. So remember, you can download all of these things, so you don't have to go my route. You can simply just download it from this one. Okay, so sorry, and save. Okay, so visually we've compared the two. Visually we've created the maps, then visually we compared the two maps to intuitively gives us indication of what may have happened with land cover, and then we actually generate the associated statistics for that to give us a quantitative analysis of my specific region of interest. Then obviously you can do it for your specific region of interest. Obviously, remember, I've also exported it, so I can go to task, and there's my pixel counts. I can go and export it to my project folder in my Google Drive. So there's quite a lot you can do with this piece of script in terms of your land use land cover for your specific region of interest, and specifically to underpin or to underscore your visual interpretation of the land use land cover change that have occurred or not have occurred between the two periods. Okay, quite a mouthful. We're going to continue with this. This is quite interesting stuff and very, very worthwhile stuff. So stay tuned. There's much more to follow. And thanks for joining me on this remote sensing journey. Please remember to like and subscribe and to share this video. And I'll see you on the other side.